Hi, in this lecture I will discuss about the three-phase inverter and different arrangements of three-phase load in which we have delta and Y transformation, and then I will discuss about over here I will discuss about two conduction modes for controlling these six switches, and then these will be 120-degree conduction and 180-degree conduction, and then I will be discussing about the current source inverter as we have already studied the voltage source inverter. So this is a kind of circuit of a three-phase inverter in which we have a voltage source and we have six arrangements of uh, switches in which we have in each arrangement, each of the six arrangement, we have a thyristor and we have a diode, and this is a kind of the circuit of a three-phase inverter, and this is a kind of voltage source three-phase inverter. And we will see how these switches are operating, as we have already understood our single phase inverter and we already know the role of these diodes, which is to pass the damp current in case the our load is a kind of complex load like an RLC load. If we have a resistive load, then there is no need of these diodes, and we already know that we switch on some arrangements of thyristors at a time for the single phase, but for this three phase I will tell you that we have two modes of operation which I will be discussing later on. These are the two diagrams in which we have two kinds of distribution of loads for the three phase inverter. One is the kind of delta arrangement of load and other is the kind of Y arrangement of load. And for the delta arrangement of load, we know that we can calculate this voltage, line voltage, if we have the voltage present at this terminal, at this terminal and this terminal. So this VA is equal to VAO, and this VB is equal to VBO, and this VC is equal to VCO. So if we know in delta, in Y transformation, if we know this Y uh, voltages, then from these Y voltages we can calculate this line voltages of the delta. So this is the first step of calculation. So we can see for the above circuit of the three-phase inverter we have two conduction modes. One conduction mode is 120-degree conduction mode and other is the 180-degree conduction mode. So what happens in these two conduction modes? Basically these two conduction modes tell us which switch to on and which switch to off. By switch I mean the thyristors. So we have two modes of operation of this thyristor. One is the 120-degree mode of operation and other is the 180-degree mode of operation. So we see that what happens in the 120-degree mode of operation. There are some instructions for these thyristors which will be on and which will be off. So we can see that in 120-degree kind of conduction mode we have only two switches on at a time, or out of these six switches we have only two thyristors which are being on at a time, and the remaining thyristors will be off, and one thyristor will be on for about 120-degree duration. As you can see below that these are the waveforms for the voltages of the Y, in which you can see this is VAO, which this is VBO, you can say instead of NO, and this is VCO as we have understood in this diagram. So in 120-degree conduction mode we have two switches which are two thyristors at a time on, and one thyristor is on for about 120-degree duration. This is 60 degree, this is 60 degrees, so one switch will be on for about 120 degree and the other will be on for the 120 degree, and so on, and one switch will be on for about 120 degree duration. And we have only two switches, two thyristors which are on at a time, and the remaining will be off. And these are the kind of voltages of the first three voltages are of the Y, and then the remaining voltages are of the delta, which are the line voltages VAB, VBC and VAC. And we can calculate only the first three voltages, and out of those voltages we can use the formula which is written over here, by which we can calculate from VAO, VBO and VCO these line voltages of the delta. In 180 degree conduction mode, we have about three switches which are on at a time, and each switch will be on for 180 degree duration. We have 60 degree for this, 60 degree for this and 60 degree for this. And same here we have specified 6 voltages, 3 voltages for the Y and 3 voltages for the delta, and we can calculate the first 3 voltages, and out of those we can calculate with the help of formula the delta voltages, which are the line voltages of these three. Now we can see that up till over here we have only studied the voltage source inverters, in which we have a voltage source over there, but over here I want to tell you about the current source inverter. So in the current source inverter we do what? We, instead of using this voltage source, we use a current source over here, and this is a kind of demonstration of a current source inverter, that this is a block which is telling us about a current source, and inside that current source what we have a voltage source, and we have that inductor over here. Thank you very much.